In this video, we'll be looking at Atwood's machine. Atwood's machine is just two blocks of masses M1 and M2. They are connected by a rope that goes over a pulley. Let's suppose that mass M2 is greater than M1. That means mass M2 is heavier than M1. Therefore, the system will begin to move. In fact, mass M2 will fall down and mass M1 is going to go up. If mass M2 moves by certain distance, let's say 5 meters, mass M1 has to go up by the same amount. This means that both blocks have the same speed. In fact, they have the same magnitude of acceleration. Let's call that acceleration as A. We want to find the value of A in terms of M1 and M2. You can pause this video here and give it a shot. Alright, let's try this problem together. So we want to find the value of A in terms of M1 and M2. So how do we do this? Let's use Newton's second law. What's Newton's second law? Newton's second law says force on an object equals the mass on that object times the acceleration. Our plan is to use F equals ma onto mass M1 and F equals ma onto mass M2. And we'll get two equations and then we'll try and solve it for A. Okay, that's great. Let's use F equals ma onto the first mass. So, first of all, we have to find what's F in this case. F stands for the total force on an object. In this example, one of the force is m1 times g, which is the force of gravity, also known as weight. And the other force is of the rope that's pulling this block upwards. This is known as the force of tension, and let's write it as F of t. Now we have the total force on an object, we can use F equals ma. Since F in this equation stands for the total force in our example would be Ft minus m1g. That's the total force and it equals mass times the acceleration. Why didn't we choose to write it as m1g minus Ft? Because we want to find the magnitude of acceleration. And since m1 is going up, so Ft must be larger than m1g. So that's why we choose this combination. Okay, we got our first equation. Now we want to focus on the block M2. So we have our first equation, we want to get the next one. In order to do that, let's focus on block M2. Hopefully we'll use F equals ma and get the other equation. Once again, the force of gravity, also known as weight, is going to pull it down and the magnitude of that force is m2g. The other force, which is the force of the rope, is going to pull it upwards and that's the force of tension, represented by F of t. So we have figured out all the forces on block M2. It's time to use Newton's second law. Newton's second law takes the form of m2g minus F of t equals m2a. That's great. We have our second equation. Let's summarize what we have done so far. So in summary, we looked at Atwood's machine and using F equals ma, we got two important equations. If we add both these equations up, we can eliminate F of t. Doing that, we get this simple equation, which is m2g minus m1g equals m1a plus m2a. We can rearrange this and write it in a neater form. The neat form looks like this. The acceleration of the system equals m2 minus m1 times g over m1 plus m2. That's great, and that solves our problem. This value gives the acceleration of both the blocks. It gives the magnitude of acceleration with which block M1 goes up and the magnitude of acceleration with which M2 goes down. I hope you found this video helpful. If you did, please consider giving me a like and also consider subscribing. I'll see you in the next one. Bye.